My name is Mridul Mishra. I work with Fidelity Investments, Senior Director there. It's a financial services company, and you can make it out by the legal statement. So whatever I say, don't invest based on whatever I'm going to say. The topic I'm going to talk about today is explainable artificial intelligence. The interesting part really is, I think Donald Trump, possibly a couple of days back, started blaming that Google is influencing too much of their decisions. Artificial intelligence, if you look at typical day since you started, whether it was Google Maps, Twitter, Facebook, whosoever used any kind of social media, there was some part of it. But that is possibly still the easier one. But now, considering it's being used for who gets parole or who gets into the jail, or it's being used for ultimately who gets elected as the most powerful person in the world, it becomes that much more important to figure out what's really happening. There are doctors who are getting replaced by it, AI. There are key decisions that who gets the loan or who doesn't get a loan getting made by AI. So it becomes that much more important to figure out why a certain decision is being made. So what we'll talk about today is why, what, and how. And considering we are in financial services, there is a lot of very regulatory requirement that if you are making a certain call, you should be able to explain it. So we'll get into a bit of detail about it. So we'll talk about what it is, why do we need it, why do we need it now, and then we will talk about some of the approaches. So one of the most interesting things I heard about AI with a lot of business leaders which we keep talking to was that it is helping us making our decisions better. But is it helping us making better decisions itself? Can we actually probe into those decisions and then figure out, is it really helping us the fair decisions which is actually good for everybody? And I have a bunch of data scientists which work with me. One of the most common conversations we have with them is, okay, so something needs to be predicted, whether it's something on the text, something on a prediction for a particular stock price movement. And they will say, okay, so we need a bunch of input data. Then there is a black box. And then magic happens. Magicians comes with the prediction. The magicians are called data scientists here. And most of the time, there is a black box. There is a miracle somewhere occurring into it. And most often, nobody has a clue. So if you go back and say, hey, I think the accuracy is not right, they will say, let's try some other model. Or let's figure it out if we can add some more features into it. But nobody is very clear in the way how it was really working. In investment management, like the way we work, there was a lot of quant models. Investment management changed 30 years back, where most of the investing is now quant-driven. But most of these models were fairly predictable. They were very linear model. If you give a certain input, the output is expected, and that's how it's going to work. But now what has started happening is there is a lot of confusion about why it's happening. And what really, when we say XAI or explainable artificial intelligence, we mean is really AI which can be understood by humans. And I made the understood highlighted there because it's not saying explain it to individuals. It's saying understood by individuals. I mean, I have a daughter who goes to 6th standard now. And it's quite funny because she will come with an answer doing her maths problem. And a lot of times you'll say, tell me the steps. Because you possibly have figured out the answer, but maybe you haven't got the concept. And we are the guardians, so we have to figure it out. The same way, in my view, we deal with AI. We say, okay, you got the prediction right, but actually explain it to me. How did you get to it? Which is, in a way, we human are like my data scientist colleague called human agents. Take that higher view of pedestal that, we know it right. Why don't you tell it to me? But before we go any further into it, I just wanted to question that notion that we are actually the higher ones. A lot of you actually followed the AlphaGo's and Lee Sedol's conversation. I specifically want to talk to you about match 2. There was a move 37 into it, which was supposed to be the match move, which literally broke Lee Sedol's any confidence into it. I just wanted to take you back on 10th of August when that game was getting played. And because this is happening in India, we are not encouraging smoking.
Listener go to smoke, and AlphaGo just play. It don't think about the opening will be there or not. So Ajab sees AlphaGo plays the move 37, and Ajab puts the stone in the board.
와, 정말 생각지도 못한.
Value.
That's a very surprising move.
I thought it was a mistake.
When I see this move, for me it's just the big shock. What? Normally human will never play this one because it's bad. It's just bad. We don't know why. It's bad.
But it's a little bit high.
Yeah.
It's fifth line. Normally you don't make a shoulder hit on the fifth line.
So coming on top of a fourth line stone is really unusual.
Yeah, that's an exciting move. I think we've seen an original move here. That's the kind of move that you play Go for.
Hey.
Interesting stuff.
This fifth line shoulder hit is
I wasn't expecting that. I don't really know if it's a good or bad move at this point.
The professional commentators almost unanimously said that not a single human player would have chosen move 37. So I actually had to poke around in AlphaGo to see what AlphaGo thought. And
the point really, the couple of times, and these are the leading Go players in Korea, in the world really, which actually couldn't figure out why did the computer do that. I stopped it there because there's a bit of discussion that when they did the analysis, they figured out there was 1 in 10,000 chance that that move could be played. It was never played by a human being ever. And the point really here is that the AI has reached a stage where we humans possibly are not even able to comprehend it and could come with the better decisions. But this was still a game of Go. This was not life or death. It was not somebody's retirement earnings and you were making a call whether you invest onto it or not. When we talk about those decisions, which is whether you have cancer or not, that is where the explanation is required. But why I wanted to talk to you about that really was that AI has reached the stage where we possibly humans are not at the higher pedestal which we think we are and want explanation. So let's talk, why do we need explanation? So bunch of people here, I have a dog. This is a Siberian Husky. How many of you have dogs? And if you're a data scientist and you want a dog, typically what you will do is you will write a classification algorithm, which will have computer vision into it, and it will look at all the passing puppies and try to figure it out. If it's that Siberian Husky is a very similar to wolf looking actually. If you look at it, even though it's a puppy, when it grows, it becomes very much like a wolf. So if you write a classification algorithm which tells whether it's a puppy or it's a wolf, this is what comes out. Let's say your prediction algorithm is doing pretty well. For 1 out of 6 cases, it wrongly classified it as a wolf and it was actually a husky. In every other case, it was doing as expected, so it was predicting correctly, which actually is a dream, honestly, if you can get this level of accuracy right. There is a problem here. And this was one of the most talked about in a lot of the explainable AI circles last year, was that when they started looking into it, that how is it actually identifying whether it's a wolf or a husky, they realized that actually it was looking at the snow around it. And what it actually created was a snow detector. So whenever it found that there is snow into it, it actually realized that it must be husky because dogs don't really be there on the snow. Now there is something fundamentally wrong. I mean, there was another example. There's an AI company here which does radiology X-ray analysis, and they trained a lot of images based on which to figure out if there is a malignant tumor into it. And what they realized was it was giving 98–99% accuracy, but when they started looking into it, they realized actually it was looking at annotations which the radiologist has actually done. So it was actually because the training data had those marking, it figured out if that there is marking into it, then it must be malignant, which is not really the objective, because then it is figuring something else out. So it is fundamentally something wrong unless you figure out how it's doing, and that's where it becomes very important to do that. But there are 4 different views why we should look at explainability. So one of it is, if there is a user, he certainly need to figure out if his loan got rejected, why did it get rejected? Was that his saving was not enough? Was that he has taken too much withdrawal? What could he do really to get it? But the second one really is even from a data scientist perspective, actually figuring out what really is happening and not just do hit and trial. Because there is actually a project called Deep Patient, and I have somehow no idea what's the love with the deep part in everything which they do, where they figured out that people who have asthma and pneumonia, they actually survive better. And they started actually going down the thread saying that, hey, what does asthma has which is giving these higher chances of survival for pneumonia patients? And then they realized actually what was just happening was there was more care being taken because if you have asthma. Asthma is not really helping you with pneumonia, but if you had just gone with the correlation and say, hey, asthma patients get better out of pneumonia, it's actually giving absolutely wrong. So if you're a data scientist, you should go deep into it and figure it out, why did it happen? In a regulated industry like financial services, I absolutely love GDPR when they started saying all the data subjects, which is you and me, have a right to go back to a company which has made its decision to explain it. I never thought myself as a data subject in this world, but so far this is where we are going to be, and there's going to be a dictator someday. So if a regulator comes in regulated industries, you have to go back and say exactly why was it done. So there's really no choice. And most importantly, if you wanted funding, whether it is your business or your boss, you really need to understand how it works. I have been part of a lot of these conversations where we explain certain recommendation, and the business person will be sitting there and then say, okay, I mean, these make sense. Explain it to me, why did it happen? And the funny thing will be, he will say, whatever made sense, anyhow I would have done it. So what's the value add? The one which doesn't make sense, which are counterintuitive, explain it to me, why did you recommend that? And you're like, let's try something else. So I think it's very important, even from a perspective of selling it, that we get that part right. Before I go any further, I think it's very important to know that explanations are, we humans are not very logical creature. I mean, all the work which has happened in behavioral sciences, behavioral finance proves it that we think we are all rational minds, but actually we are not. We don't spend as much time with family as we want. We don't invest for our future. We all want to be getting up early and go for a run, but most of us don't eat that extra candy at the dessert at the counter. So the learning has been always that, you know what, the way people will look at explanations is that it need to be contrastive, which is if there has been a certain decision, if somebody's loan got rejected and what we figured out was that his saving was only 5 lakh, the next question will be, okay, so if it was 10 lakh, would that have approved it? How many of you have watched Rashomon Effect? There's a 1954, couple of you, great. It's the classic Japanese movie, those of you like black and white Japanese movie. And there's one killing of a samurai, and the people look at it from different perspective. Each one of them are telling the truth, but everybody's truth is different. And the point really is that if you are talking to different people in the group, what you really realize is the way they are looking at that information is very different. It's very contextual, so the same explanation doesn't work at the level of the person whom the decision is impacting versus his boss versus the executive. Always it focuses on the abnormal, so it's not whatever they were expecting, nobody actually asked why did that happen. So ultimately the point really is that anything which looks abnormal needs to be explained. What we learned really was that good explanations actually in some way are coherent with people anyhow what believed. whenever we start challenging what they believed, and a lot of cases where what happens is that there was a certain way certain decisions were being done, whether it was a call to talk with a particular dealer or a broker, or how trading gets done, selecting a particular exchange, humans have been doing in a certain way. The moment model starts coming back, which is contrasting with what they were doing, explanation becomes that much more important. And my learning really was it doesn't need to be truthful. It's good if they're truthful. A lot of times it just is a simplified version of reality, because the real decision making is so complex that it is just not possible to be truthful in the legal sense of explaining all the causes of it. It is good enough if you cover most of it. So I was saying that in investment management industry, which I work with, we have been doing quantitative investment for 30, 40 years now. I mean, from like 1980s, that has been the fad. And most of the time, those quant models, the way they used to work was kind of a linear model. So this is from one of the McKinsey report. And what they show, that line which you see, the green one, is how typical linear regression models used to work, which was very monotonic, very predictable, how the answers will be. But once you start getting into a lot of those machine learning models, what you start seeing is those graphs. In this case, it's a churn analysis for, I think, one of the telecom companies, where the way relationships are coming out cannot be linearly represented like it. So the representation itself has become very, very complex. And I remember, I mean, not too long back, maybe 10 years back, the factors which we used to look for predicting where the market is going was as simple as, let's say, PMI, which is Purchasing Managers Index. Or we just used to look at inflation data, what is coming out, the job numbers which is coming out, and we just, based on that, used to go ahead and predict where the market is going to be. Now, with the big data and being able to capture everything, any of these models typically runs into 100 to 200 factors now to just predict that same thing which was being done with 3 or 4 factors. So both that we have more complex representations and we have a lot more features has what really made it that much more difficult now. The way we put internally the view on this really is that there is a choice to be made. There are on one side interpretability concerns. On the other side, there is accuracy. And like they say, you don't get everything always. There is always a choice to be made in terms of whether you want more accuracy or you want more linear model, which is more interpretable. But actually what we are trying to do really is, when you show a graph like this, everybody says, hey, we want best of both. So what we really try to do is, can we start moving some of these approaches to the more of right, where we still get an accuracy which is higher than linear model and still try to get interpretable. It is still not there as it was easier with the earlier models, but we are trying to get it. But the other factor which plays the role here is the whole computation power. So those of you who did the CAP theorem in college possibly remember that you can only pick 2 of these. If you really want a deep learning model and which need to be interpretable, we really need to figure out what those different weights were and possibly give the sample feature set with all possible values. The computationally it becomes so intensive that it is just not feasible to do it. So there's really a choice to be made between 3 axes, not even 2, which is what you want more. Accuracy, interpretability, and how much computation can you really throw at it. So far that was the context I was putting in terms of why do we need it. And from here, we will possibly move on to how it has been moving. Before I start talking about specific ones, I have to say that this has been an area which research has been behind the adoption of it. Industries possibly have moved on a lot in terms of using AI without figuring out how do we explain it. It was a lot like when electricity came, everybody built it, but they never thought about building circuit breakers. And when somebody's electricity blasted the whole grid, they said, you know what, I think we need to do circuit breakers. So a lot of this is happening, is still coming out of research, still is something which is happening in the universities, still coming out from the research wings of the large organizations and not necessarily something which is a productionalized version of it which is available. There are two broad buckets of it. One of it is if we can explain globally how it's happening, which is look for the model, look for all the predictions and possibly explain it at the global level. The second one is local interpretability, where you're looking at a single instance, you're looking at a single prediction, figuring out if for me coming from my office to this predicted 55-minute, why did it predict for me, rather than saying everybody why the prediction was really that much. And what we have seen really is the local interpretability is possibly slightly ahead. If you're trying to do global, it's still that much more challenging. How many of you have used Lime before? Yeah, so Lime has been possibly the most popular, at least the most common one, which has been talked about in at least 1.5 to 2 year part of it. Fairly simple concept. You take it, you perturb the input data which was there, go ahead and use that to figure out how it gets done, which Lime we will talk about a bit more later. But the more interesting one which have started coming is the counterfactual explanations. The interesting thing which we figured out recently was, like in US, the credit score were always supposed to be explainable. If somebody gives FICO, which gives the credit score in US, has been using neural networks since 91, 92, and they anyhow had to go back and explain it to it. If they said your credit score is 820, why did they come to it? So there was, they had a couple of patents which expired, I think some time back, which actually was explaining part of it. And that gives one of the approaches to look at when you are doing explanation, like FICO's reason report. The other thing is actually look at interpretable architecture, and actually at the very start of your problem definition itself figure out if is it worth going to something as complex as a deep learning model, or just we stay with something which is more interpretable, because in some cases maybe you have to take a choice itself. And then there are the future of it which is coming in terms of exposable latent features like lens. So Lime has been a method for fitting local interpretable model that can explain single prediction of any black box machine learning model. So it is model agnostic. In a lot of ways, it doesn't care what you did put internally. They are based on local surrogate models. So what they try to do is, if the representation which you have is very complex, and what you are looking for is a specific area where you need explanation, what they do is they say, let's define a local surrogate model for that specific area, which, because it's trying to focus on a very specific area, it could be a lot simpler version than the complete model of it. And then they generate a data set consisting of different samples which are there. And that data set, they trains an interpretable model weighted by the proximity of the sampled instance which you were trying to explain. So they look at how close is the sampled instance of what you were trying to explain, and then use it. I mean, one of the cutest example which they have, which possibly gets used a lot really, is a Labrador playing a guitar, which gets explained. And the way they have done really is, what you see down is they have created many versions of it, they have perturbed it, grade different parts of it, and what they show really is that the probability of each one of them matching to it. So in this case, the face of it kind of is a giveaway that it was a Labrador. If you just look at the body of the guitar, it was giving its acoustic guitar. But if you look at the neck of the guitar, it says it possibly might be electric guitar, and it gives that higher probability. So it's a slightly confusing picture, because the body of the guitar is acoustic, but the head of the guitar or the neck of the guitar is electric. But what it is trying to show really is that if I'm telling you that this was a Labrador playing an electric guitar, why did I say that? Which is very useful in a lot of scenarios, as we were talking about. It works for other cases. It works for text inputs. It creates separate separate data sets for the text input which are there, perturbs it, and then creates which one of those features actually resulted in the final prediction, really. It's pretty good for localized explanations if your need is being able to explain a specific prediction, and I think it's possibly is the best to get started with if you need it. I think it's possibly the simplest one. You get going in a day or two. Humans interpretation is pretty good. It doesn't try to be the most complicated interpretation, so it's not exhaustive, but it figures out what are the most important features which need to be used for explaining it. And because it's not exhaustive, it doesn't work if you work in an industry where everything needs to be explained to auditors or regulators for each and every decision. It doesn't work in a lot of those scenarios. The counterfactual explanation. This is, I think, fairly intuitive way it works. A lot of work was done in Microsoft Research. They did some work earlier this year. I think DeepMind published a paper late August onto it to say how you can start using it. There are a couple of GitHub projects which try to implement it currently. The way I find it very interesting, it really tries to be the way humans think about it. So once you find something, I mean, in Bangalore, if you stay, the traffic is the biggest thing to worry about. So if I have to go back home, there possibly are 3 routes, and if it says take it via MG Road, I will always think, hey, but why MG Road? Why can't I just go and take the outer ring road and possibly go it? So it just really, for every prediction, says that if X had not occurred or something else would have happened, what would have been the output? Which is very human way of thinking. So if you're looking at a prediction and there are 20 feature sets, which has education level, it has age, it has gender, it has the race of it. Most time what you're trying to figure out really is that, okay, if the gender changed, is there an angle to it? If the age was slightly more, will that change it? Which is very intuitive way of thinking it, and it kind of tries to simulate that, which is very interesting. So the way it works is fairly simple. We change the feature value of an instance before making the prediction, analyze how the prediction changed, and that tells how much was the impact of it. Again, it's used for very instance-specific predictions. That's an example which gets used a lot in the counterfactual explanations. And the way to read this is that you're trying to predict students' average grade of the first year at the law school, based on the GPA before they joined it. So what you see as column 2 is the GPA before they joined the school. The law school entrance exam, which is column 2, and the race, and 0 being white and 1 being black. And then what it did was it created a counterfactual data, which is it created a GPA which is quite similar to what was the original GPA. It created law scores, which is quite different than what was there. But it did something very racial. It actually converted most of the people to whites to show that actually if you want average grades, then there is a very strong correlation that you need to be Y. It's a fairly racial model to look at, but it gives you a picture that underlying model possibly would not have anyhow stood if it was to be explained, if somebody goes to court and say why the GPA score was not predicted right. So in a way, it gives you an answer that race and possibly your law school entrance exam results are one of the key features. The implementation of very early stages, I mean, there are a few GitHub projects which are there. We played around a bit with it. The interpretation where it works is fairly clear. I personally think it's very intuitive to think in that lines. It's model agnostic. It doesn't do anything specific to a model, and it's fairly easy to implement. But if you are playing around with it, I think it's fine. If you want to use it in a production-like scenario, maybe it's not there. I personally thought this was a very interesting concept. The reason reporter, and this is, I mean, if you go to FICO and search for reason reporter, you'll find the earlier patents which they had on this, which have become open now. I can give you, the way this works really is that, let's say a new data point come and credit score was explained. What they do is they kind of bin things. So they look at different features, like feature 1 to n, and then they put scores, and then they put bin. So what they realize that, let's say first feature is the salary of the individual. And they will say if you were getting between $100,000 and $120,000, your score will be 850. If you were $30,000 to $40,000, it will be 650. And when they have to actually explain, that way they put kind of bins for each and every feature. And then when they have to go and explain why was a certain score given, they go back and figure out which is the closest user data matching with what the output has been. So in this case, 860 was the output. They realized that actually 850 was fairly close. The feature bin for that feature 1 was in that range. So what they go back and say is that reason code is 65, and the user possibly is for that feature is in that feature bin. So it, rather than dealing for individual feature values which are there, it actually tries to put things into bin. It's a very useful concept, because if you think about a lot of discrete data sets which are there, stock prices, maturity dates of bond, it's very important to group them into something which is human comprehensible and something which can be related, rather than dealing with each and individual values of it, which is a very interesting implementation of it. The other thing which we saw really was that whatever model does, there always will be some human knowledge or a domain knowledge need to be put, specifically if you are in a regulatory industry. A lot of time data will tell that a certain gender or a certain race or a certain age group has been given certain privileges. And data keeps on telling it that if somebody comes back with the age beyond 60, maybe you don't give him a house loan because it has never been given. Now the problem with that really is that if regulator come back and they figure it out that you have been discriminating against people because the age was higher, that becomes a problem. So what we've started realizing it that you need to still have some rule, and in this case, like the example which I was talking about, if you realize that age has been a critical factor for model to actually score somebody's credit score down, you manually flip it. Either you go back and impute the data and say, I will make sure that people above 60 also start getting it, or add it to the final scorecard and say that fair enough, let model predict it, but I will add some extra points just because if you are in that age group, because we have seen a lot of this discrimination based on the data. So that's the real world problem, because most of the data sets which we get will be skewed in some way based on how human agents have been working on to non-ideal world. And going forward, if you have to start making it more and more come to what we want the world to be, there has to be that domain knowledge part of it added to counterbalance what the data was trying to say. So with that, this possibly is the last slide in terms of summary. I hope I have been able to convince you that it's a very important for acceptance of model learning, machine learning, that we are able to explain it. It's not only for the users to know or for auditors to know, but even for the practitioners who are building these models to know, because a lot of times there is something more hidden than what meets the eye. And if it gets recognized by a regulator or in the production, that's a lot bigger. So it certainly needs to be a focus area for everybody. It's not yet there. It's possibly will take a year, 2 years from now for it to become mainstream and get adopted into it. A lot of work is happening. Recently we're talking to Salesforce Einstein team, and they have done explanations on some of the decisions which it tries to make. And it will keep on getting better as it goes along, but that's a focus area which need to be there. And if you are in a regulated industry which makes these critical decisions, there really is no choice. I think before it goes into production, you really need to get that act together in terms of making the model explainable. So that was all the conversation I had in the slide. Thoughts, questions, feedback?
So we spoke a lot about the framework, right? So let's say that I'm building a model in a production environment, and I see the more progressive companies are thinking of building an XAI layer as part of customers. Now, implementing a model like Lime, let's say at the first pass, seems that it builds a model for each point, right? And I think it builds a sparse linear model and so lasso or something like that.
Right.
That's computationally very expensive.
Correct.
So what could be the way out? Let's say I want to do that. I know it's a good way to go ahead, but it's killing me computationally. And I don't think there is any GPU implementation for Lime. Or
It's not.
like that
Yeah.
for the moment.
Yeah.
So how do you go ahead?
Yeah, very, very good question actually, and one of the reason of putting that computation slide really is just becomes prohibitive really in terms of computation to actually add it for every record. The way at least we have been looking at really is that there are some use cases where there is no choice, and what we make sure is that once the model has been evaluated based on the accuracy part of it, we actually make sure that one of the part of QA before it goes into model really is something which is explainable using one of these model. I'm not allowed to say which one it works really, but there are very few use cases where each and every one of them need to be explained at that level, where interpretability requirements are that high. One of the things which we have learned really is at the very early stages when we are even having a conversation that what is the business problem, we ask this question, so ultimately, how interpretable do you need? Could it just be, I mean, if you're building a model that who will click on your ad, really don't care. I mean, it's okay. It's few cents here and there, no big deal. But if you're going to predict somebody's X-ray is malignant or not, interpretability is that very important. Maybe cost for computation is justified. So I don't know if there is that clear a framework which you were hoping, but that's how we were trying to. Yeah, so I mean, the way, at least the thinking has been that it should be part of your QA process in a lot of ways, especially for those use cases where the auditors might come back and you would have to explain, or you get into this get sued for a specific decision or a life or death kind of conversation. So it starts getting very specific to those use cases where there's no choice, even though it's computationally very costly, it possibly need to be, it will delay overall rollout of your model, but it is, for those industries, those use cases, it's better to possibly be safe.
I have sorry, I have a question. Sorry. First of all, I have to apologize. I joined in the middle, so I didn't fully see what you presented. I'm from the financial services domain. So of the techniques which so in financial services, you have to be very clear in explaining to a customer what is that you have to change so that your credit score can improve. Okay. So solutions like Lime is not like surgical enough to clearly communicate. So of the techniques you have seen, is there a clear recommendation you have of being able to explain a deep learning score of what the customer should do to improve the score?
I mean, I think what you should possibly look at what FICO did with the Reason Reporter and trying to bin it, because the point really is when the customers are asking for it, they are not really very specifically trying to figure out what your model did. More often than not, the question is really, so what should I do to make sure my credit score goes up or my loan gets approved? And what, if you come from that angle to figure out which of those should be the action should be taken to change the decision, I thought that Reason Reporter does a pretty good job of abstracting the whole problem and then coming back and saying, these are the reason codes you should look back. And then if you look at your feature bins, it in a way goes back and says, this is what you should work on really. So I think that possibly is something worth looking at, specifically in financial services.
Thank you.
So my question was about, we are going from features to outputs, and there have been studies which do the output back to features. Does that sort of help in these kind of explainable scenarios?
Give me an example of what you're saying. I'm not sure.
Suppose we build on some feature set,
Right.
and we are getting to some outputs.
Right.
There have been approaches wherein we flip it around and we say, these are the outputs, and we are trying to predict the features. And then we compare.
I mean, it used to work pretty well when we used to have linear models, whether it was logistic regression or anything which was explainable. This is the simple coefficient, you add it and possibly get it. But like I was showing you, I mean, if your representation starts getting too complex, which it does in a lot of cases, specifically deep learning, if your feature set runs into 100, somebody backward creating that would be quite a challenge. I haven't seen it personally, so if it is possible, great, but I haven't seen it.
Excuse me. Yeah, I have a small question. Now, one of the ways of finding out the explainability in a model is probably using an old technique of AI when in the days of symbolic AI, the reasoning and the logic frameworks were there. So, are there works going on where we are going to combine them with deep learning models, or something called planning and learning and things like being tried or attempted?
Yeah, so I mean, you're right. I mean, the world was fairly simple at that point of time. An example I was giving you really was that, I mean, when we used to predict market movement, the factors which we used to look were fairly straightforward. We just looked job data, inflation data, what is the confidence level which is coming out. And in those cases, it was like expert systems where domain, a lot of people, how many have used expert systems before? As a bunch of people, yeah. Those who haven't heard, this was like, what, 90s? 90s AI? 70s AI, mid-90s AI, yeah. And in those times, it was pretty easy to go back and start explaining, because it was, in a lot of ways, it was coming out of somebody's mind. The feature set was fairly limited. It was a lot easier to describe. I mean, once we get into hundreds of features, 200, 300, and nobody really knows how they're correlating, it's very difficult. I mean, the only way really is, the crudest way is impute a feature, remove it, see the impact, impute the other one and see what the impact is, or look at the row level and counterfactual do it. I don't know if that golden era of explainability will come back, because it's a lot more complicated word now. Sorry, yeah.
I have a question.
Sure.
My question is the other side of the problem. Do you think when it is about the regulator, or say somebody who is an authority on the subject, I'm not talking about general customer, do you think that there is a gap in the very understanding of behavior of complex systems, okay, in the education part of it? Because when we say counterintuitive systems, that's a huge area of its own. And when you are talking about non-linear and highly interactive system with, say, 200, 300 variables, both in time and space, working together, so most probably there is an educational gap itself available in the different disciplines, where people are not taught at a university level or some other level, which can lead to, people trying to, even though they may say counterintuitive and all that, but they may still look for something which is democratic.
Okay, so this is getting into a different range of philosophical debate about it. But I mean, I don't understand how my car works, really. I mean, I expect a functional job of it to do, take me from point A to point B. It has been working as an industry, it has reached the level of credibility. But if you watch old Hindi movies and all, there used to be those scenes where the smoke will come out and you actually open the hood and see where water to be put. So there was a time where you actually need to know it. Maybe we will reach the stage where we'll start trusting the decisions which are coming out with the AI algorithm and say, okay, if AI has said it, it knows more than it. We will get that level of credibility. But we are at a very early stages, and the decisions it is making are life-changing for people. So my take on this will be, maybe society will accept it. Maybe regulators will say, if machine has said it, it's move 37. We don't know whether it is good or bad, but humans just don't get it. We are not there yet. I mean, that is more like a fundamental measure for calculation. How? Yeah. No. No, I haven't actually. No, I haven't. But it's called Shapely. Okay, I will certainly look at it. Cool. Correct. Yeah, H2 is doing some great work, absolutely in that area. There will be vendors here, so yeah, maybe no comments on specific ones. Cool. Yeah.
So you talked about the explanation and how to bin is one of the means of explanation. Is there a techniques or tools or another method to explain as well? Can we put some methods rather than manually interpreting how to explain? Can't we not put another model to
AI to explain the AI? Yeah. So Yeah, I mean, so a lot of this is in a way generating, even if you use Lime, in a lot of ways it uses a surrogate model which generates those explanations. But the point really is this is for human consumption. So if finally you have to convince a end user, you don't want him to give him whatever machine is giving you. At least at this stage, we still need that kind of verification to be there. You want to?
Mine was only comment. I think addressing explainability is definitely a head-on problem. Even before that, particularly when new industries trying to adopt AI, I think the first thing, the least possible thing that they could do is to have their systems reproducible. Right from data, basically version your data, version your code, version your models. At least it's reproducible, it is auditable.
Yeah.
Explanation basically is a layer that can be addressed as things.
I agree. I mean, yeah, you need to be certain level of tall before you try achieving it. And if you're not versioning your model and data, then yeah, some way to go. Totally agree. Cool. Somebody was saying something there, some comment feedback.
Yeah, I was thinking on the future of this, right? So do you think you will be needing explanation in like 50 years? Or I mean, right now we're very interested in this, and I'm interested in this. But I'm thinking like in 50 years, if we are a society with everything's AI and stuff, I don't think we will care about explanation and stuff. I mean, it could be happening that I mean, I have no idea how my car works.
Yeah.
And I don't care.
Yeah.
And maybe that will happen in the future.
Yeah, yeah. I mean, fairly valid point. And the funny thing is, somehow we humans have this urge to understand everything. It's not like we understand. So if you go and listen to the news, market goes up. They will say, oh, the market has gone up because this data came back and because of certain geopolitical tension. And if market goes down, the same reason will be used. We have that urge. I mean, I remember when Trump was getting elected, everybody was betting on Hillary to win. And we were saying if Trump wins, it will be a disaster. It's 2 years. And we can give reasons. He gives reasons better than I can give. So I think there is more a psychological reason to ask for justification rather than really a need to understand it. And I get your point. I mean, in some way, we don't really understand a lot of complex system. Once that level of trust gets built, maybe nobody will ask. It's just a commodity. But if you watch any news channel, I think all the experts are trying to give justification for any and everything, but the world is just too complex to be explained in those sound bites. So I think it's more a psychological urge than a technical thing, really. Cool, thank you. Thank you.